Hello everyone. In this section we will discuss about optimizers in TensorFlow. So these are the topics we are going to cover. First we will discuss what is optimizer in TensorFlow, and then we will discuss about the algorithm that is gradient descent optimizer. In the end, we will discuss the different types of optimizer in TensorFlow. First, we will discuss what is optimizer in TensorFlow. Basically, it is a technique that is used to decrease loss by modulating different parameters and weights. Hence, it is minimizing the loss function for better accuracy of the model. The optimizer class is declared with given arguments, but it is also important to remember that no input tensor is needed. The basic optimizer provides the TensorFlow that is tf.train.optimizer function, but this optimizer works only in an older version of TensorFlow, that is 1.x, that can be any version. Now TensorFlow has released the latest version, which was 2.9.1, and this optimizer will work on it, that is tf.compat.v1.train.optimizer function. After this we will discuss about gradient descent optimizer algorithm. So basically it is an algorithm that is used to calculate the minimum value for a function, and it is also used in supervised learning to minimize error function and calculate the optimal values for the parameters. We have to calculate the minimum value for a function, and the gradient descent algorithm discover what should be done to minimize loss function using partial derivative like addition number that can be a 0.8 and the subtract number 0.28. So in gradient descent we start with a random guess and then we will move to the correct or the exact answer. In gradient descent, parameters are optimized. Now let us take a mathematical example and understand the working of gradient descent optimizer. So here is the example. In this example we have defined the square function in it. For example, fx is equal to x square. So in this example first we have defined the tf dot variable and assigned the value in it as a 15. After that we have assigned the parameter that is name and given the value as new tens along with the d type that is tf dot flow 32. So after that we have used the log and the square function and assigned the values in it. In the log function we have assigned the tensor value that is 15. After that we have assigned the log value in a square function. So now we want to gradient the value. For this we have used the tf.compat.v1.train gradient descent optimizer and assign the value 0.5. We have defined a function that is optimized, and within this we have run the session tf.compat.v1.session name. But before you can use this session you have to import the tf.compat.v1.disable eager execution function. So after running the optimized function value, so as you can see that it displays the value that is 15 and the step value is 10 that we have mentioned in a loop. So as you can see that the major difference in the between these values is 0.5 because we have mentioned in the optimizer function that value will be 0.5. So moving forward, now we will discuss the different types of optimizer in TensorFlow. These are the optimizers we are going to use in a TensorFlow, but we will discuss only few optimizer. The first one is stochastic gradient descent. After that, momentum, adaptive gradient optimizer, adaptive delta optimizer, RMS prompt, and ADAM. Now we will briefly understand about these optimizers. The first one is stochastic gradient descent. So the word stochastic means a system or process linked with a random probability. Hence in stochastic gradient descent, a few samples are selected randomly instead of the whole data set for each iteration. In gradient descent, there is a term called batch, which denotes the total number of samples from a data set that is used for calculating the gradient for each iteration. So here is the syntax of stochastic gradient descent optimizer in TensorFlow. This is the function name, that is tf.keras.optimizers.sgd. So within these functions we are going to use the few parameters The first one is learning rate. Basically, this parameter defines the rate at which the algorithm updates the parameters, and the by default value is 0.01. The next one parameter is momentum. It accelerates gradient descent in the appropriate direction, and the data type is a float type. By default, the value is 0.0. The next one parameter is nestro. This parameter defines whether to apply nestro momentum or not, and the type is boolean value, and by default the value is false. So last parameter is name. This is an optional parameter and it specifies the name of the operations. The by default value is SGD. Now we will discuss our next optimizer, that is Adam. Adam is among the topmost optimization technique used today, and in this method the adaptive learning rate for each parameter is calculated, and this method combines advantages of both RMS propagation and momentum that store decaying average of previous gradients and previous square gradients. So here is the syntax of tf.keras.optimizer.adam function, and within this function we are going to use first parameter, that is learning rate. It is basically a rate at which algorithm updates the parameter, and by default the value will be float type and the value is 0.01. The next one parameter is beta 1. It is an exponential decay rate for first moment and the constant value will be always 0.9. The next one parameter is epsilon. This parameter used to sustain numerical stability, and by default the value is 1 e raised to power minus 0.7. The last one parameter is name. This parameter defines the name of the operation and it is an optional parameter. Now we will discuss about the example and see how we can use the Adam optimizer in a model. In this example, first we have imported all the libraries. After that we have downloaded the dataset by using tf.keras.dataset.mnist.load_data. So TensorFlow allows us to read the MNIST dataset and we can load it directly in the example as a train and test data set. Downloading the MNIST dataset, we will convert the pixel into a floating point values by using .as type attribute. So we are converting the pixel values into floating point values to make the prediction. Changing the numbers into a grayscale. In this example, I have mentioned the grayscale variable as a scale_value. So as a pixel values, range starts from 0 to 256, but I have assigned the 255 value in it. It will convert into a range from 0 to 1. Now we will understand the structure of a data set. So after executing this code, records, that is 60,000 in the training data set and the 10,000 record in the test data set. So and every image in the data set is the size of 28. Now we will create a model by using sequential model. So sequential model allows us to create models layer by layer and it is limited to single input as well as single output stack of layers. So within this parenthesis I have used the flatten. Flattens this defines the input provided without affecting the batch size. For example, if inputs are shaped like batch_size without a feature access, then flatten adds an extra channel or you can say a dimension and it will return a batch_size with the access, that is 1. Along with that I have mentioned the activation and assigned the sigmoid function in it. The first two dense layers are used to make a fully connected model and are the hidden layers. The last dense layer is the output layer which contains 10 neurons that decide which category the image belongs to. Now I am going to compile the model by using model.compile. Within this I have discussed about compile function. Compile function is basically used here that involves the use of loss, optimizer and matrix attributes. So here loss function is sparse categorical cross entropy and the optimizer we have used, that is Adam. After that I have fit the model by using model.fit and assign the epochs that is 10, batch size and the validation. Basically, approach tells us the number of times the model will be trained in forwarding and backward passes, and the batch size represents the number of sample, that unspecified batch size, and by default the value will be 32. But in this case I have assigned the value that is 2000. So after executing this code, the approach value will be represented as the 10 and it represents the loss and the accuracy. So now we will find the accuracy of the model. So we got the accuracy of our model, that is 92% by using model.evaluate on the test sample. So our last optimizer is RMS propagation. RMS stands for root mean square propagation, and it is an updated version of adaptive gradient with new changes, and it is used in simple momentum instead of nested momentum. Now we will discuss about the example and check how we are going to use the tf.keras.optimizers.rms prompt function. So in this example, first we have imported the TensorFlow library and then use the tf.keras.optimizer.rms prompt function, and within this function we have assigned the learning rate value, that is 0.1. After that we have created a tensor by using tf.variable and assign the value, that is 10.04, and then we have used the new optimizer.minimize function and assign the new loss we have created by using lambda function. So after executing this code, the value will be 9.683772. With this we have completed the optimizers in TensorFlow.